Today we're going to 2 graphs of other trig functions. Now we obviously, sine and cosine are a big two. All right. That's why I spent more time on sine and cosine than the others. That's why we did that extra packet, and that's why I want to see how you do with it. We're going to look at tangent here today, and then we're going to look at the other 3 tomorrow. All right. So to me, sine and cosine are up here on importance. Tangent's kind of like here, then it's kind of the rest of them. You know what I mean? And that's kind of how I'm going to appropriate the time for them as well. So we'll look at the tangent one today. When we get through this, we'll just stop right there. We'll pick up the other 3 tomorrow, just kind of look at them kind of briefly. We're not going to go quite as in-depth with those guys. All right, so tangent function looks a little different. So remember, let's just flash back to cosine and sine. Remember, our sine looks like this, right? It's really rough. But it starts at the origin and goes up. This would be your sine one. And then cosine looks like this. It starts up here and goes back and forth from there, right? So sine starts at the origin. Cosine would start at either the max or the min. All right, so today, the tangent x, we're going to start just like we did with sine and cosine. We're going to do a little chart of values, and then we're going to talk about some of the characteristics of it, as well as show the graph of the base form of this. So this is just tangent of x, a straight tangent of x. So for the values, I didn't fill them in for you. They're going to be a little different. We're not going to look quite as many. All right, I'm going to break this down. So tangent is kind of skinnier for a cycle. All right, so the sine and cosine, we had a period of 2 pi, correct? This one here, we just have a period of pi. I'm going to go ahead and write that one to start with. So it's kind of shrunk down a little bit to how far a period is. And we're going to look at some weird numbers here. I'm going to show you why. We look at x, when x is 0, our y value is going to be 0, so it's going to start at the origin as well. Okay, then from there, we have some funky stuff that happens. All right, so let's look at, let's skip ahead to, this guy here. I'm going to look at pi over 2, just halfway through our cycle. Now, if you do the tangent of pi over 2, guess what you're going to get? You're going to get undefined. So that feels weird, doesn't it? What's that? That's the middle of a period. Okay, that's why I use that, and that's why I skipped ahead. We're going to fill in the ones in between those 2 numbers. Like I skipped 6 of them. Okay. All right, so there's something weird going on at pi over 2, right? For it to be undefined, it doesn't feel right. All right, so let's find a couple other ones. Let's go 6, pi over 6. If we go pi over 6, we're going to get 0.6. Okay, not bad. Pi over 4, there we're looking at 1. So we're growing. I'm all right with that. Let's go a little bigger. Let's go pi over 3. Pi over 3, we got 1.7. Now we're growing pretty quick here, aren't we? You know, sine and cosine, they maxed out at 1. All right, let's keep going a little bit. So I'm going to pull in some funky numbers here just to show you what happens. So as I get closer to pi over 2, let's go with 5 pi over 12. Okay, 6 pi over 12 would be pi over 2. So 5 pi over 12 is actually 3.7. Oh, I'm getting really close now. We could go over 24. Let's go to 36. So let's go 17 pi over 36. We're getting pretty close. That's actually going to be 11.4. So we're getting really, really darn close. Now I'm going to go one really, really high. All right, I'm going to go 89 pi over 180. That's about as close to as close to pi over 2 as you can get, right? That number would actually be 57.3. Now, when you're doing these, you're probably not going to ever have to go this slow. Pi over 6, pi over 4, pi over 3. Yeah, these guys, not so much. But what I wanted to do, I wanted to do that to show you what's going on. So this looks really weird, doesn't it? Okay, and then if you would go negatives of these, it would do the same thing. So this is what the tangent function looks like. The tangent function, we know it intersects at 0. All right. And a pi over 2, there's something weird going on. Put a line here, so it'll be pi over 2. And then we'll just go pi, 3 pi over 2, 2 pi, and 5 pi over 2. So I just went every half pi. All right, and I'm going to go a half pi in the opposite direction as well. We'll see why in a second. Now, remember in the end of college algebra, when we talked about asymptotes? Remember those? Okay, asymptotes were the values where things didn't exist. Okay, there was a break. There was something changed over. Piecewise functions. Piecewise functions. Remember those? We had like holes in the graph. We had asymptotes, those types of things. That's what actually happens with tangent. We have some asymptotes. So there is actually an asymptote at pi over 2. That's why it's undefined. So when I have an asymptote, what you want to do is draw a dotted vertical line right here. Okay? Now, if you have one at positive pi over 2, you're also going to have one at negative pi over 2. All right? And actually, we're going to have one at 3 pi over 2 and 5 pi over 2 as well. So I'm going to go ahead and draw those asymptotes. All right, and at the same time, we are going to have an intercept point at each one of these intermediate ones. If I find what tangent of pi is going to be, it's 0. Tangent of 2 pi, it's 0. So I have 3 x-intercepts there. Yeah. Put in a calculator. It's going to say error. All right. And if you think about it too on your unit circle, tangent is y over x. Tangent of when x is 1, it's going to be 1 over 0, which is undefined. All right, so this is what we have so far. Now, if I look up here at my points, what happens? So as I start at 0, I go into 0.6, 1, 1.7, 3%. Keeps going up higher and higher. Do you think of a function that sort of works like this that we've seen in the past? Any ideas? Definitely not linear, right? What's this? Yeah, what's that one? A cubic function, right? It looks like it has some type of exponential growth. Okay, it's not growing consistently, it's getting higher and higher and higher. This looks very similar to a cubic function. This would look like this. Okay, it's like the right half of a parabola. And it would, on the other side, it would do this. Okay, same way. And then it just keeps repeating over and over again. Okay, here, here. Whenever we find, that's what the tangent function looks like right there. This here would be 1 period is when I'm back to that same spot. Okay, remember before we had like or the sine or cosine. The sine was whenever I went up, back down, then back to that same spot. It's kind of the same concept, but when do I return to 0 again? Well, from here to here. That's one period. Okay? Whenever we graph this guy, so sine and cosine, we would find the max and min, find the x-intercepts, and then connect the dots, right? This one, we're basically going to find the intercepts and then draw the lines in between the intercepts. Okay? Now, I think that's still, it's not quite as pretty as sine and cosine, but that's still pretty attractive to the eyes, don't you think? Yeah?
I don't know, yours is pretty nice.
That's like spot on, isn't it? What's that? Because every time, so again, back to that unit circle concept. Okay, every time you hit one of those quadrant points, 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi, right? We have a 0 and we have a 1, some combination, right? Now, if we think in terms of the unit circle, it's y over x is your tangent value. So whenever I hit the one that's straight up and down, okay, this would be 1, 0, this would be 0, 1, negative 1, 0, and 0, negative 1. Agreed? The tangent's y over x. Y over x here would be 0 over 1, right? 0. Here, 1 over 0, which is undefined. Here, we have 0 over 1, negative 1, 0. Here, 1, negative 1 over 0, undefined. So actually, every time that we hit this value or this value, that's what's changing there. Okay? That's where that asymptote is. It's undefined. There's something going on. We can't have that value. Okay? Now, if I would multiply it by 3, then it changes things a little bit, you know, or add or subtract something to it. Same as sine and cosine, it shifts it and those types of things. But every time we have to hit one of those spots, then we're going to have something that's undefined. That make sense? Yep. All right. Whereas on the other side, sine and cosine, we're either looking at an x value or a y value. The worst thing we're ever going to have would be a 0. That's when our intercepts are. All right, so let's look at the characteristics here, a little bit of it. Yep, you're not one of the rotations. All right, so here we go. The domain of just the base one would be all real except those asymptotes, right? So this would actually be except, I forgot the word, odd multiples of pi over 2. I say odd multiples because pi over 2 would be 1 over 2. This would be 2 pi over 2. That's an even multiple because the top's even. 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. Okay? The domain would be all real numbers except for odd multiples of pi over 2. Your range here, well, it goes from negative infinity to positive infinity, so what's your range? All real, or negative infinity to positive infinity, either one. Now, we are going to have vertical asymptotes at the odd multiples of pi over 2. All right, we're going to have an x-intercept. It's going to be midway between each pair of asymptotes. So every asymptote you have between that asymptote and the one before and after it, there's going to be an x-intercept midway between those two. All right, and lastly, even or odd, well, like I said, it's very similar to a cubic function, right? That'd be symmetric about the origin, so therefore this would be even or odd. Odd. Okay. and it has origin symmetry. Questions so far? That's all right. All right. Let's try a couple different variations of this one. Well, first off, we got to figure out the steps to do it. All right, sine and cosine, you had to figure out what the period, the phase shift. You had to figure out your x-intercepts and your five key points, right? We're going to have to do something similar, but the process is different for the tangent. Like I said, we're going to worry more about the x-intercepts. So here's your process for graphing a tangent function. The form y equals a cosine bx minus c. All right, so what you want to do, you want to find two consecutive asymptotes by finding an interval containing one period. So the original one, we have asymptotes at pi over 2 and negative pi over 2. So what you're going to basically do is take whatever's in that parentheses and plug it into a compound inequality. Plug it in here and solve it for x. So then you're going to have a pair of consecutive asymptotes of both these. All right, I just split this from a compound inequality to separates. Second, you're going to identify an x-intercept, which is midway between the consecutive asymptotes. Third, you want to find the points on the graph at 1/4 and 3/4 of the way between the consecutive asymptotes, and those points have y-coordinates of negative a and a respectively. That's kind of like your magnitude or your amplitude, sort of what that is. All right, then you're going to use steps 1 to 3 to graph one full period of the function and add additional cycles to the left and right as needed. So a lot of times for a tangent function, they're going to say graph from this point to this point. Okay, sine and cosine, it might say what graph one period or 2 periods. This one might say graph it from pi to 3 pi or something like that. All right, so a lot of that sounds really confusing, doesn't it? It's okay if it does. I think it sounds confusing when you read it. You're still awake. I have to come start kicking any desks. Max is thinking about it. All right, so we are going to graph y equals 2 times the tangent of x over 2, and we want to graph it from negative pi to 3 pi. So I'm going to go from negative pi to 3 pi on our graph. So I'm going to follow the steps exactly like they're written up there, okay? You just scroll down a little bit to give me a little more room. But the first one, we want to find the two consecutive asymptotes. All right, so step 1. I am going to take whatever is in parentheses, or what would have been in parentheses, and plug it into this guy in the middle. Okay, so we have negative pi over 2 is less than bx minus c less than pi over 2. In this case, all I have is x over 2, though, right? There's no parentheses with adding anything on. So I'm just going to take this, I'm going to plug that right in the middle of the inequality. This would be x over 2. All right, so then I want to solve that inequality. Remember back to solving the inequality, you can do the cover-up method where you cover up the right side, figure out what you have to do to solve for x, and then do it everywhere. So in this case, we're going to have to multiply everything by what? 2. Okay, multiply everything by 2. So 2, 2, 2. And that's just going to simplify it down to negative pi less than x is less than pi. Okay, so that means I have asymptotes at negative pi and positive pi. All right, that's the first thing. Second thing, I want to find something. I want to find midway between those two that I just found. So if I have negative pi and positive pi, what's halfway between those? 0. So in this case, x equals 0. All right, in step 3, quarter and 3/4 of the way between the consecutive asymptotes. Well, if I have negative pi and pi, dead center is 0, right? That would be my half, essentially. I can split both of those other halves in half, okay? So in that case, I could look at it that way, or the other way I could look at this, it's just my negative a and a. What's my a term here? It's 2, right? I'm just going to make it easier on myself. All right, so a is 2, therefore I'm going to have negative 2 and positive 2 as my 2 points. And where would that occur at? Well, that would occur halfway between negative pi and 0 is going to be what? Draw this up here. Let's see. Someone just said it. Yeah, negative pi over 2. So here's my pi. Here's my positive pi. Okay, essentially this is halfway between, right? So I need 1/4 of the way and 3/4 of the way. Well, half of pi is pi over 2. And then same thing up here, pi over 2. Okay, so at negative pi over 2, my y value is negative 2. At pi over 2, it's over 2. So that there is very similar to the quarter period thing we did when we were finding our 5 points for sine and cosine. Okay, we just split that whole section into a quarters. All right, let's graph this puppy. So I'm going to put negative pi, this will be negative pi over 2, 0, pi over 2, and pi. Okay, now we want to go the whole way to 3 pi, right? So here should be 2 pi, here 3 pi. Guys, you with that? I just graphed every half pi there. All right, so I have asymptotes at negative pi, at pi, okay? Then I'd also have an asymptote at 3 pi. How did I figure that out? This whole section is 2 pi wide, right? Okay, negative pi to pi is 2 pi. So I've had another 2 pi wide. So there's another asymptote. All right, so graph what I know. Well, halfway between is an x-intercept. Halfway between pi and negative pi is an x-intercept. Boom, that guy's right there. I just found those 2 additional points at pi over 2 and negative pi over 2. And they both have a value of what? 2. Okay? So at negative pi over 2, I'm at negative 2. At pi over 2, I'm at positive 2. All right, so it looks something like this and this. And then I would just replicate the same thing in that next section. Okay, so 2, negative 2. Missed that point. Here. 0. Boom. Boom. There you go. That is 2 tangent of x over 2 graph from negative pi to 3 pi. All right with that? Yeah? All right, we're going to do one more. what I want to do, let's go through the process. There's 3 steps, and then you guys graph it. That work? All right. So last one for the day. I'm gonna have y equals tangent of x plus pi over 4, and we want to do it for 2 periods. Okay, I'm gonna go 2 periods on this guy. All right, so step 1, we got to find our asymptotes, right? This case, I'm going to have negative pi over 2 less than pi over 2. I want to take bx plus c, or bx minus c, sorry, plug that in. In this case, that is everything that's in these parentheses, x plus pi over 4. So I'm going to solve this guy for x. I'm going to have to subtract pi over 4 from everywhere. Boom, boom. It would stay that way. Remember, this is technically it would really be a shift, right? So typically, by form, it should be minus. This just means we're going the opposite direction. Okay. So right away, can you see what happened? Probably shifted everything to the left, pi over 4, right? All right, so we go ahead and solve this guy. Negative pi over 2 minus pi over 4. What's that going to be? Negative 3 pi over 4, right? Less than x less than pi over 2 minus a quarter. That's going to be a quarter pi. Oh, quarter pi. Okay, got that taken care of. Next thing, if you can't see it, the difference between 3 pi over 4 and pi over 4, halfway between that would be negative pi over 4, right? If for some reason you're going, oh man, I don't know how to do this, you can add them together and just find the average. Let's just write that out one time so you've seen it. So I could take negative 3 pi over 4 plus pi over 4 divided by 2. Okay, so that would be negative 2 pi over 4 over 2, which would be, flip that up, multiply by 1/2 on top, and negative 2 pi over 8, or negative pi over 4. So it's exactly the same that we just saw, right? So this is my x int. All right. Lastly, my quarter pi and 3/4 pi. Okay. So everything's broken down again into 1 pi is the length of it, right? I have 3/4 and 1/4. So my 1/4 would be what? A lot of fractions I'm throwing at you. Draw this out. I think this helps to see it a little bit. Okay, so if I have negative 3/4 pi, that's my initial. My last one is pi over 4. Halfway between is negative 1/4 pi. These are all in fourths, right? So I'd have another one right here between 1 and 3/4, right? So 2/4 pi would be what? Pi over 2. Okay, and then here, quarter pi, add a quarter pi to that, that gives me 0. So this would be my 1/4. This would be my 3/4. Okay. So my quarter would be negative pi over 2. And the value there would be the negative of my a term. What's my a term? Nothing here, so it would be 1. Okay, so that would be negative 1. This guy, with my 3/4 term, would be 0. And then it's my positive a term there. All right? Do you have enough to graph it now? Yeah. Go ahead and graph it. Give you about 2 or 3 minutes.